Look closely at this city street. The movement, the light, the texture, it all reads as organic, but underneath, it is entirely artificial. Today's generative algorithms build physical realities that easily pass our basic visual checks. Systems like Midjourney, Sora, and Veo output native 4K video with synchronized audio. They have learned to render depth of field, lens flare, and motion blur, the exact optical flaws we used to rely on to prove a physical camera was present. The manipulation isn't invisible. The issue is that human biology evolved to recognize predators and read facial expressions, not to detect pixel-level geometric failures or sub-second timeline anomalies. Relying on a quick glance is no longer safe. Catching deepfakes requires shifting from passive viewing to a deliberate clinical observation process. We call this process a digital autopsy. It requires breaking media down into 4 specific modalities: spatial geometry, temporal consistency, auditory alignment, and cognitive logic. As synthetic generation scales, the ability to spot where these models violate the laws of physics and logic becomes a required literacy for navigating the information age. The first step is analyzing the static space of a still image to find where an algorithm fails to maintain geometry. Machine learning models struggle to accurately render complex human anatomy. If you examine this hand resting on the table, the algorithm has fused 2 digits together and added an impossible joint. Beyond anatomy, we look for the plastic texture effect. Real photographs capture tiny, randomized imperfections, but generative models tend to over-polish the surfaces they create. This split-screen chart illustrates the difference. On the left, we see the randomized noise pattern of a physical camera sensor. On the right, the AI diffusion model exhibits a flat, uniform noise distribution, effectively erasing skin pores and organic grain. Next, trace the light. Generative models frequently cast shadows diverging in multiple directions, ignoring the physics of a single light source. Street signs, corporate logos, and background text often melt into garbled, dreamlike symbols. Algorithms prioritize the aesthetic shape over actual linguistic structure. Static AI images fail because they are optimized for overall aesthetic harmony, not strict adherence to optical physics. Moving from static space into chronological space introduces a massive computational burden, maintaining geometric consistency over time. This timeline flowchart illustrates temporal drift. As generation moves from frame 1 to frame 60, short-term memory of shapes degrades. This causes face morphing, where eye distance subtly shifts. It also causes flickering textures, making a brick grid chaotically shift. Fine details suffer from object permanence failure. Rings, shirt buttons, or items resting on a desk will simply blink out of existence between frames. Notice background drift here. Though the environment should remain static, the architecture behind the subject warps and bends impossibly as the camera pans. An algorithm can hallucinate a flawless single frame, but the computational tax of short-term memory makes sustained time its most vulnerable flaw. In the auditory space, the generation process splits. Creating a synthetic voice is one challenge. Synchronizing that speech with human mouth movements is another. Generative audio produces clean syllables, but lacks the sharp intakes of breath, the varied pacing, and the organic emotional friction of a real human speaking. Forensic analysts detect lip sync manipulation using the MBP rule. To pronounce M, B, and P, human lips must close completely. Generative tools consistently miss this microsecond physical requirement. Here, the waveform hits an M sound, but the mouth remains open, triggering a detection alert. Digital models can approximate the sound of speech, but replicating the rigid, mechanical physics of human anatomy proves to be a far steeper hurdle. The final modality shifts from sensory perception to cognitive logic, looking at how AI constructs written language. Language models generate text with extreme polish. They produce perfectly balanced paragraphs, but rely on formulaic, repetitive sentence structures that rarely vary in cadence. This confident formatting acts as a mask. The tone is authoritative and grammar flawless, but the core factual statement is completely fabricated, a hallucination. In written form, artificial intelligence mimics the cadence of an expert, while possessing absolutely no underlying comprehension of the truth. As these models refine their physics and temporal memory, spotting visual and auditory glitches with the naked eye will eventually become insufficient. We must deploy new systemic defense strategies. The first step is executing a reverse image search to track down the original context and establish an accurate timeline for the media. We also have to interrogate the invisible data. Inspecting C2PA metadata standards allows us to trace the true origin of a file and see exactly what software touched it before it reached our screens. Operating online today demands a new baseline. Every piece of unverified media must be treated as synthetic until cross-verification proves it is authentic. The fidelity gap between generative outputs and reality continues to shrink. Navigating this environment now requires consistent manual verification. The algorithm itself is just a tool. The true vulnerability lies in our willingness to extend blind trust to unverified interfaces. Survivability in a synthetic world depends on the critical tools used to identify what is actually real.